Hello students, we are going to study the solid state, which is a part of the states of matter. You are already aware about it. What are the states of matter? We know that states of matter are in the form of solid, liquid and a gas. In standard 11th, we have already studied related to the gaseous states and the liquid states. In the gaseous states, we studied it. Boyle's law, Charles' law, Gay-Lussac's law, Dalton's law, etc. in a detail with all its derivations. Whereas in the liquid state, we have simply studied the certain terms in the form of definitions like vapor pressure, diffusion, surface tension, evaporation, etc. Today, in this unit, we will study certain theories of the solid state. We know that what are solids. All of you are quite aware about it because you have already studied in the lower standard what are solids. Can anyone from you explain? Yeah, correct. It's having definite shapes. They are having definite volumes. They are having maximum intermolecular forces of attraction. Good. But do you all know it that all these properties of the solids depends on some factors? All these properties of the solid depends on two factors. The first one, that is nature of constituent, and the second one is a binding forces that is operating between them. Okay, constituent particles means the number of atoms or molecules or ions present in the crystals to form a solid substance. Whereas the binding forces means the types of bond formed between them, that is maybe in the form of ionic bond, covalent bond, metallic bond, hydrogen bond, or maybe van der Waals forces which are in the form of London forces, or maybe in the form of dipole-dipole interactions. Okay, now the students, the question arises in your mind that when we are aware about the properties of the solids, when we are knowing it what are the solids, then why to study? Who made all these things? We will understand this factor that why should we study the solids in the detail with the properties, that is to prepare some new materials which might be useful to us in our day-to-day life. For example, if we want to understand that how we can study it or why it is useful, then giving an example, I can say that in the olden times, the people used to eat their food by serving it in the leaves. Later on, they studied it, the solid properties, and they prepared clay pots. They prepared some utensils like plates, bowls, glasses. Again, it became a difficulty that because of the water they might be dissolved or broken out, or the molecules may be changed, so they prepared it from the metals. From the metals like stainless steel or copper utensils or maybe silver utensils, etc. Again, they found it as a difficulty that they are too heavy to hold them. So they made it as in certain materials from melamine polymers which are lighter in weight. Like that, we can give it as in many other examples that in a day-to-day life, we need some changes. And these changes are very necessary for our life to make it comfortable. And that's the reason why it's necessary to study the properties in detail. One of the property of the solids till now you have studied it, that they cannot flow from one container to the another, which is already indicated as they are having definite shape and fixed volume. But do you know that the same solids, they are also having a property of oscillating from their positions. They can oscillate from one position to the another and get back to the same position. Now let us understand the oscillation of the solid particles with the help of certain examples. The first example, if I take it, if we take a piece of wood and apply the pressure by your hands on it, can you change the shape or size of that wood piece? Yeah, your answer is no. We cannot change the shape or size of the wood by applying the pressure of the hand on it. But now, if you have been told that take the nail, hammer on it, what will happen? You will find that the nail will penetrate into the wood by hammering it without removing any of the constituent particles of the wood from it. Now try to do the same thing onto the iron rod. Take an iron rod, take a nail, hammer on it. What will you find? Yes, you will find that you cannot hammer the nail into that iron rod. This shows that the oscillation of the particles are also not possible in each and every molecules. They depend upon the type of intermolecular forces present between those particles. If you are having a stronger forces of attraction, the oscillation will be less, like that we saw it into the iron rod, whereas the weaker forces shows the oscillation of particles is more, like by hammering a nail into the wood. That means these particles having an oscillation depends on the forces. It also depends on other property of the solid. This is simply and one of the example to understand the oscillation of the particles in the solid state. There are many other factors which supports or restricts the oscillation of the particles in the solid state. We will study them in the later on part of the chapter. But now, first of all, let us recall the general properties of the solids before we understand or try to explain different properties of the solids other than what we have studied in the lower standard. In the lower standard, we are aware about some general basic properties. Can anyone of you explain? Yeah, good. They have definite mass. They have definite shape. Good. They have definite volume. Good. Molecules are quite closer to one another. Perfect. Intermolecular forces are very strong. Good. The property of oscillation that just now we discussed. Good. They are rigid. Yes. They are incompressible. Good. Because of the other properties, then these general properties, the solids are classified into different types. Like we can say that the solids are classified into crystalline and amorphous substances. Okay, now let us study first what are crystalline and amorphous solids. In your frame, In your video you can see it on the left hand side. Certain figures are shown, as well as in the bottom also the figure are shown. The first figure on the left hand side indicates it's a crystalline solids, whereas in the second figure it's an amorphous. Similar way, in the bottom you can see it, the first figure is a crystalline solid, whereas the second one represents the amorphous solids. Now how to understand it from the figure? What does it shows? Why they are considered as crystalline? Why they are considered it as an amorphous solids? Now see it in the first figure. Those solids are having a regular arrangement of the particles, and it's in the long ranged, and that is the reason why these molecules are considered to be as a crystalline solids. So crystalline solids are defined as the particles which are arranged themselves into a regular arrangement for a long ranged order are considered as crystalline solids. You can give it as an examples as common salt, graphite, diamonds, etc. Whereas in the second figure it shows that those solids do not have a regular arrangement of the particles. They are having a short ranged arrangement. After a certain arrangement of the molecules of 5 or 6 atoms, you can see that they are changed, the shape has been changed. That is why they are considered to be as an short ranged order of the particles and are known as amorphous solids. For amorphous solids, you can give an examples like glass, rubber, etc. Now let us understand what is the difference between crystalline solids and amorphous solids. We will study these differences with the help of certain properties. You can see it on your frame that the difference between the crystalline and amorphous solids have been shown. But with the help of those differences, these differences are written or shown on the frame only to get in question answer out the question in your exams. But if we want to understand them, we will use that the crystalline solids shows long range of an arrangement of the particles. As a result, they have definite geometrical shape, whereas amorphous solids are having short range of an arrangement of the particles and so shows irregular geometrical shape. That will be the first difference that we can see it on the geometrical shapes. One is having regular and the other one is having irregular. Now because they are having a regular arrangement of the particles in the crystalline solids, they have sharp melting point. What is the meaning of sharp melting point? Sharp melting point means when you are taking it as any substance and immediately it melts at one specific temperature. That means you can take it as an example that water, it melts at fixed 4 degrees Celsius. If I take one piece of ice, or if I take it as a smaller or a bigger piece of ice, everyone will melt at a fixed temperature, that is 4 degrees Celsius. Whereas if we take it as an amorphous solids like glass, then they are having a range of melting point. That means all their molecules are not going to melt at the same temperature. As already I told it, example of glass. Glass has a range of melting point of 1400 degrees Celsius to 1600 degrees Celsius. That means it starts to melt at 1400 degrees Celsius and it gets completely melted at 1600 degrees Celsius. That is the reason why it is considered that amorphous solids are having a range of melting point while crystalline solids are having sharp melting point. The third difference that we give it, that is, if we take it as a crystalline solid, cut into the two pieces by using a sharp edged tool, you will find that both the pieces are cut into the two parts having smooth surfaces. Whereas, on the other hand, amorphous solids will split itself into irregular surfaces. If you try to understand it with an example, you can say that when you take it as an any kind of an wood and try to cut it with a sharp edge material, you will find that both the surfaces are identical. If you put them in front of one another, we won't be able to arrange themselves exactly in between each other. Whereas if you take it as a glass, cut it with a sharp edge, the surfaces are not smooth. It is immediately told that be safe, otherwise it will cut your fingers, or wherever it is being touched it will cut the skin. So that shows that they are having irregular surfaces when they are cut. The fourth point is crystalline solids are anisotropic in nature, whereas amorphous solids are isotropic in nature. Now, what is the meaning of anisotropic? Anisotropic means when the physical properties of the solid substances like electrical resistance, refractive index, etc. are measured in the crystalline substance from any direction, you will find that the values won't be same. They differ from place to place, they differ from direction to direction. Then such solids are said to be as an anisotropic in nature. Now, isotropic substances means those substances which shows that the physical properties along any direction in the crystal is same. Then such topics are considered to be as an isotropic in nature. Hope you have understood all the differences of the crystalline and amorphous substances. Now see it in your frame in the video and try to answer it or write the question for it as what is the difference between crystalline substances and amorphous substances, which is very important according to your examination point of view. Okay, in the previous frame we studied it that what is the difference between crystalline and amorphous substances, but according to our curriculum it is been framed in it that we want to study only basics of amorphous, while we are going to study a crystalline substance in a detail with a certain topics. But before going for it, we will simply first of all complete it as a small topic of amorphous solids, where we want to understand only and only related to what are amorphous solids, how are they be prepared, and what are their examples. You can see it in the frame that you are being given the definition how to prepare the amorphous substances. Amorphous substances are prepared by heating the substance at a very high temperature, and then on immediate cooling it forms amorphous solids. This means that heat the substance to like 50, 60, 100, 200 degrees Celsius. That means it gets converted into its somewhat molten state or liquid state. And immediate cooling, that means within a fraction of time, by putting it into a chilled container, immediately bringing down the temperature to its solidifications, then it is get converted into amorphous solids. Example, if we want to understand this thing, you can see it as in glass. I don't know whether any of you have seen the glass factories or not. During the preparation of the glass materials, the silica and the other required components are mixed together in a proper proportion, heated to a very high temperature. When they melt, they immediately mixes together, and later on, immediately on cooling it into a desired shape, the glasses are formed. So this is a one particular method for preparation of amorphous substances. The another characteristic of the amorphous substance is using the word as supercooled liquid, or you can say that they are pseudo solids. Now what is the meaning of pseudo? Pseudo means false. Yeah, it's a false. When we want to understand that why these words are used for amorphous substances, if any of you would have seen the old buildings around you, or even at your home, or those buildings which are constructed 10, 15, 20 years before are having in glass framed windows, you can see it that from the top of the portion of the window it's a thin, whereas in the bottom it is a thick. From the top you can see that the window is moving, its glass is moving in between the frame, whereas in the bottom it's a stuck up. That shows that the glass has flown from top to bottom. This shows that the flow of the glass indicates that it's a liquid form, but actually it's not a liquid, and that's the reason why it is used the word as super cooled liquids or pseudo solids. Okay, even simpler. Let's take some other example. All of you have seen the rubber band. Yeah, that rubber band, when you're putting it in some drawer, or if you are taking a page and you're putting it as a roll on it and then putting the rubber band on it, put it aside for 3-4 days, 5 days, you will find that that rubber band gets melted, gets separated, and it's been broken out or gets stuck to the this paper, or if you are placed into the drawer, it has stuck to the drawer. Why it has happened so? Rubber, actually it's a liquid. You know that rubber is prepared from the latex, so that is super cooled. Another example which you have seen it from the childhood, that is, you are having an eraser, a plastic scale, it's placed in your compass box. Some for 2 or 3 days or 5 days you are not using it, any of them, compass box is aside. After that, when you are trying to remove the scale, you find that a rubber eraser that is got stuck to it. Did you apply any kind of a Fevicol? Did you apply Fevistick? No, nothing. No sticky materials have been used. Still it is stuck to the scale. If you are applying a small force on it, then only it gets separated. At that time you can see that the certain shape is there onto the scale also. That is because of the rubber that is used for the preparation of eraser has flown out and gets stuck to the polymer. That is the reason why it is told that these are the super cooled liquids. Got it? Understood? Okay. Okay students, hope so that you have understood all what we studied it today in the topics and discussed it. We will discuss it in our next lecture about the crystalline solids in a more detail, because as per our curriculum we have to study the crystalline solids in a complete details, and we will discuss it in our next lecture. Before going for the next lecture, there are the certain questions in front of you on your screen which you have to try to answer it. Answer those questions, and still at any point if you find out any queries or unable to understand it, feel free to contact me, as the contact number is shown on your screen. Thank you.